This pink planet isn't a prop from a sci-fi movie. It is a real celestial body existing in our universe. But let me tell you, don't be fooled by its appearance. This is actually one of the most terrifying crime scenes in the cosmos. This pink planet is GJ504b, located 57 light-years away from Earth, and it is blatantly violating all the laws of planetary birth. It is absurdly heavy, weirdly hot, and its orbit is so large it feels like a mockery. Mainstream theories suggest that giant planets can only be born close to their stars, yet this one shines alone in the distant deep space, like a homeless cosmic wanderer. This completely baffles astronomers. Its existence is like a slap in the face to textbook theories. What's even crazier is that it might only be 160 million years old, which, on a cosmic scale, makes it a mere newborn. But how can a newborn have 4 times the mass of Jupiter? Where did it steal its material from? Who gave it the energy? Scientists have proposed a shocking theory. GJ504b might not have formed through traditional pathways, but rather as the product of violent collisions between stars or even galaxies. This means that the pink planet we see could be a massive scar, a permanent mark formed by high-temperature atmospheres when its host star was torn apart. If this theory holds true, a cruel law we have yet to understand hides deep within the universe, the mutual predation, capture, and transformation among planets. And GJ504b serves as a silent warning before our telescopes. Let's start from the beginning. In August 2013, a research team from the National Astronomical Observatory of Japan used the extreme adaptive optics system of the Subaru telescope to directly image this planet for the first time. When the image appeared on the screens, everyone in the control room was stunned. It was a profound magenta glow, like a rose burning in the depths of the universe. This was the first time in human history that a planet orbiting a sun-like star was directly imaged, not inferred, through indirect methods, but actually seen with our own eyes. However, as researchers began to analyze the data, their excitement quickly turned to confusion. First was the issue of distance. GJ504b is located about 43.5 astronomical units, AU, from its host star, with 1 AU equating to the distance from the Earth to the Sunday. This means the planet's distance to its star is much farther than Neptune's distance to our Sunday. Neptune is about 30 AU from the Sun, while GJ504b is a full 43.5 AU away. This distance made everyone uneasy. Why? Because the mainstream theory of planetary formation, the core accretion model, simply postulates that in the early stages of a star's birth, it is surrounded by a protoplanetary disk composed of gas and dust. In regions closer to the star, dust particles slowly condense into a rocky core. When the core grows to about 10 times the mass of Earth, its gravitational pull becomes strong enough to frantically accrete surrounding hydrogen and helium gas, eventually swelling into a gas giant like Jupiter or Saturn. However, this process is subject to a fatal limitation. The farther away from the star, the thinner the material in the protoplanetary disk, making it exceptionally difficult for a planetary core to grow. Scientists have calculated that for regions beyond 30 AU, according to the core accretion model, it is entirely impossible for a giant planet to form within a reasonable time frame because the matter density there is far too low. It is like trying to build a skyscraper in a desert where even finding bricks is difficult. Unfortunately, GJ504b resides in exactly such a region, proudly existing with 4 times the mass of Jupiter, seemingly mocking human theories of planetary formation. One might ask, is it possible that the planet initially formed closer to the star and then migrated to its current outer position? This possibility is known to scientists as planetary migration theory. In our own solar system, for example, Jupiter may have undergone a similar migration process. The problem, however, is that planetary migration typically occurs when a star system is very young, during the stage when the protoplanetary disk still exists. During that period, gas drag would push the planet to alter its orbit. GJ504b's host star, GJ504a, is a G0 type star with a mass and luminosity slightly higher than those of the Sunday. According to early studies, the age of this star system might only be 100 million to 200 million years. Although young, the circumstellar disk around it would have already dissipated by this stage. So, what force pushed this massive planet to such a distant orbit? Adding to the perplexity, subsequent studies have questioned this age estimate. A 2017 study using more precise spectral analysis suggested that GJ504a might be much older than previously estimated, potentially boasting a history of several billion years. If this conclusion is correct, the mass estimation for GJ504b must be reevaluated. It might not be 4 Jupiter masses, but rather closer to the mass of a brown dwarf. In other words, it might not be a planet at all, but rather a failed star. This leads to another theory, the gravitational instability model. In the early stages of stellar birth, if the protoplanetary disk is massive enough, certain regions might directly undergo gravitational collapse to form a high-mass celestial body, similar to the formation process of a star itself. This process does not require the prior formation of a rocky core. Instead, a giant planet is directly generated in the outer reaches of the star system. If GJ504b formed this way, then it was never a planet to begin with, but rather the host star's little brother. Due to insufficient mass, it couldn't ignite hydrogen fusion in its core, meaning it could never become a true star. Brown dwarfs are precisely this type of celestial body. Dubbed failed stars, their masses fall between those of the most massive planets and the least massive stars, typically ranging from 13 to 80 Jupiter masses. If GJ504b is indeed billions of years old, its mass might exceed the 1-3 Jupiter mass threshold, making it a brown dwarf rather than a planet. Yet, even so, its existence remains shrouded in mystery, because not even the gravitational instability model can fully explain how a celestial body could stably exist in such a distant orbit for billions of years. So, what exactly is the story behind that unforgettable pink hue? This might be GJ504b's most fascinating and bizarre feature. Typically, the planets we observe are either blue like Earth, due to atmospheric scattering of blue light, or red like Mars, because the surface is covered in iron oxide. GJ504b's pink color, however, originates from a completely different mechanism, its own heat. The planet's surface temperature is around 237 degrees Celsius. While that might not sound incredibly hot, keep in mind that this is a celestial body located far from its star, receiving almost no radiative heating. The only reason it can maintain this temperature is that its interior is still slowly releasing the gravitational potential energy accumulated during its formation. It is like a piece of iron just pulled from a forge. Though removed from the heat source, the thermal energy stored inside continues to radiate outward. GJ504b's atmosphere consists of silicate-rich clouds and a variety of complex molecules. As its internal heat radiates outward, these substances absorb specific wavelengths of light, resulting in a unique magenta hue. This color is itself a clue, indicating that the planet's atmospheric composition is unlike that of any planet in our solar system. Jupiter and Saturn exhibit yellowish-brown tones due to the ice crystals and sulfides in their atmospheres. Uranus and Neptune appear blue because the methane in their atmospheres absorbs red light. In contrast, GJ504b's pinkish tone hints at an atmospheric chemical environment we have never seen before. In 2020, an international research team used the Very Large Telescope, VLT, to conduct spectral analysis on GJ504b, revealing surprising chemical features in the planet's atmosphere. They observed the absorption signatures of methane, but its abundance seemed lower than theoretical expectations. Given the temperature and pressure conditions, methane should be the dominant carbon compound in the atmosphere. However, observational data showed a relatively weak methane signal, suggesting that currently ununderstood atmospheric processes are altering the planet's chemical makeup. Researchers believe that vertical atmospheric mixing might be bringing carbon monoxide from deeper layers up to the upper atmosphere. thereby suppressing methane formation. Alternatively, uneven internal heat distribution might be creating a complex three-dimensional atmospheric structure. All these findings indicate that GJ504b is much more complex than we anticipated. At this point, we must face the hard-to-accept possibility that GJ504b might not be a planet in the traditional sense at all. In the astronomical community, the boundary between planets and brown dwarfs has long been a subject of debate. The International Astronomical Union defines a planet as a celestial body orbiting a star, but it has not set a strict upper mass limit. Some scientists advocate using 13 Jupiter masses as the dividing line, as this is the critical mass required for deuterium fusion to occur. Other scientists argue for a distinction based on formation mechanisms. If a body coalesces from a protoplanetary disk, it is considered a planet. If it forms through direct collapse, it is a brown dwarf. By the latter standard, if GJ504b formed via direct collapse due to gravitational instability, it is essentially a failed star that just happened to be captured in the orbit of a true star. It is akin to a pair of twins, where one grows into an adult, while the other remains forever trapped in the infant stage. Regardless of GJ504b's true nature, its significance to humanity is revolutionary. Prior to its discovery, our understanding of exoplanets relied almost entirely on indirect methods. These included the transit method, which observes the dip in brightness when a planet passes in front of its star, and the radial velocity method, which measures the spectral shifts caused by a planet's gravitational pull on its star. While effective, these methods can only provide basic parameters like orbital period, size, and mass. They cannot reveal details such as a planet's appearance, atmospheric color, or the presence of clouds and storms. GJ504b is one of the first exoplanets to be observed via direct imaging technology, allowing us to witness its mysterious pink glow with our own eyes for the first time. This marks astronomy's entry into a new era. We no longer merely infer the existence of exoplanets through indirect evidence, but can directly observe and study their atmospheric compositions, potentially even discovering chemical biosignatures of life in the future. In 2021, the James Webb Space Telescope was successfully launched. As the most powerful infrared telescope in human history, it will be able to observe exoplanet atmospheres with unprecedented precision. Although GJ504b is not a priority target for the Webb telescope, directly imaged planets of this kind lay the foundation for future exoplanetary atmospheric studies. Perhaps in the near future, we will be able to analyze the atmospheric spectra of hundreds of similar planets, establishing an exoplanet atmosphere database to more deeply understand planetary formation and evolution. All of this began in the summer of 2013, when the Subaru telescope's lens was pointed at an unassuming star in the constellation Virgo, capturing that ghostly pink glow. The story of GJ504b is far from over. Scientists are still engaged in heated debates regarding its age, mass, and formation mechanism. This celestial body could be a giant planet that formed in the outer reaches of its star system, a wandering planet that migrated from the inner regions, a brown dwarf that formed simultaneously with its star, or even an alien planet from another star system captured by gravity. Every single possibility points to a cosmic operational mechanism we have yet to fully comprehend. 57 light-years away, that pink planet continues to quietly orbit its star. What kind of miracles might it reveal to us someday in the future? It might turn out to be a standard giant planet with a unique formation process, or it might represent an entirely new class of celestial objects, thereby forcing us to redefine the very concept of a planet. One thing is certain, however. The discovery of GJ504b serves as a reminder that the imagination of the universe far exceeds that of humanity. We may think we understand the laws of planetary formation, but nature always manages to present exceptions, and these exceptions are the gateways to deeper truths.